welcome to The Explainer. Okay, today we're jumping into something, well, it's pretty wild. It's a proposal for the future of AI that smashes together some seriously advanced engineering with, believe it or not, the hidden music of pure math. And the whole thing kicks off with this one simple idea. The way we're going to get to the next level in AI, it isn't just about making models bigger and bigger. No, it's about building them smarter, with more architectural depth. So, what exactly is holding AI back right now? Well, a lot of folks in the field are starting to talk about this thing called the architectural wall. And when you look at it, the difference is pretty stark, right? On one side, you've got our current AI. A lot of them are, well, kind of shallow. Their knowledge can be brittle, and they have this huge problem called catastrophic forgetting. I mean, you teach them something new, and poof, they forget what they learned before. So the next frontier, where we want to be, is all about deep reasoning. Having an AI that can evolve on its own, but in a governed, safe way, and of course, can keep learning without wiping its memory. Okay, so to bust through that wall, a totally new kind of architecture has been designed. Let's dive in and see what makes this thing tick, because it's really different. All right, it's got a bit of a mouthful for a name, GSAI-HRVA. But here's the gist. At its heart, this is a framework that's built from scratch to improve itself, to think in these really deep, complex ways. But, and this is key, all while staying safe and under control. One of the coolest features is this 5-level government structure. You can almost think of it like a little government inside the AI. It's a system of checks and balances that makes sure that as the AI learns and evolves, it stays stable, it stays efficient, and it sticks to its original purpose. It's not allowed to just, go rogue. And this thing is absolutely packed with cool new tech. We're talking a reasoning engine that can think at different speeds, kind of like shifting gears. It can handle a constant fire hose of data without breaking a sweat. And it has these really smart ways to protect its most important memories, so it doesn't suffer from that catastrophic forgetting we were just talking about. Okay, so just to recap, we've got this super advanced, self-evolving, self-governing AI. Got it? Good. Because this is where the story takes a completely unexpected turn. We're about to swerve right into the world of pure mathematics and number theory. For literally centuries, we've all been taught that prime numbers are the random, chaotic, unpredictable bits of math. They just appear. But here's the question. What if they're not? What if there's some kind of hidden order that we've just been missing this whole time? So this new theory does something that's just brilliant. Instead of looking at the primes themselves, it looks at the gaps between them. And then it treats those gaps like frequencies, like musical notes. From there, it uses a pretty standard tool called a Fourier transform, which is basically just a way to break down any signal into its simplest parts to see if there are any pure harmonic notes hiding in there. And what it finds is absolutely wild. A constant rhythmic pulse, a heartbeat, at about 2.34 radians, ticking away inside the prime number system. This suggests they aren't random at all. It's like they're part of some huge, resonant, harmonic system. And this prime scalar field, as they call it, isn't just some simple little beat. No way. It has a really clear harmonic structure. It's fractal, which is just a fancy way of saying the same patterns repeat over and over again, no matter how much you zoom in or out. And it all comes together to form this incredibly complex, multidimensional web of information. Okay, so here's the synthesis. This is the big what if. What happens when you take that super smart, self-evolving AI framework we talked about, and you ground it? You base its very structure on this fundamental, hidden code of the universe we just found in prime numbers. Well, the first big win has to do with the AI's memory, what engineers call its latent space. This is a great way to think about it. It's like the AI's internal map of the world. It's the absolute foundation of everything it understands. So instead of building that mental map on a foundation of just random noise, which is how a lot of models work, you structure it using the natural, stable, and repeating harmonics from the prime numbers. It's like giving it a perfectly stable blueprint to build its reality on. Okay, synergy number 2. This fusion makes the AI's ability to improve itself way, way more efficient. Think about it. If a normal AI trying to evolve is like someone wandering around a maze blindfolded, just hoping to find the exit, this harmonic approach is like handing them a map and a compass. Suddenly, the AI isn't just stumbling around in the dark, randomly trying things to get better. Nope, it becomes this guided search. It can actually follow the wave patterns in the prime field to find the best solutions, these harmonic optima, so much faster than before. And the third big benefit? This harmonic foundation makes the whole system tougher, more resilient. It basically acts like an anchor, holding knowledge in place and stopping the AI from forgetting all the stuff it's worked so hard to learn. I mean, this is a really profound shift. Protecting important memories stops being a guessing game. It's no longer just a loose strategy. Instead, it becomes a core principle, where the most important knowledge is literally anchored to the most stable, fundamental structure we found, the prime field itself. Okay, so this all sounds amazing, almost like science fiction. But the rubber has to meet the road, right? The big question is always, is this actually practical? Can you even build this thing without needing, I don't know, a supercomputer the size of a planet? And the answer is, surprisingly, yeah. The analysis shows the extra computing cost is almost nothing. The whole prime field thing can be calculated once ahead of time, and the total extra training time is only about 10%. I mean, for the kind of boost we're talking about, that is an absolute steal. And the payoff looks massive. The base AI, the GSA HRVA, is already a beast. On a really tough reasoning test, it hit 45% accuracy with just 7 million parameters. Now, that might not sound huge, but it's outperforming models that are thousands of times bigger. And adding this harmonic layer, well, that's expected to push its performance even higher. So this whole idea, this fusion of super advanced AI with the deepest truths of mathematics, it really leaves you with a huge question, doesn't it? We just found this incredible, deep, structural order in a place everyone just assumed was pure chaos. It really makes you wonder, what other secrets is the universe hiding from us, right there in plain sight?